The topic we are doing is current of electricity. The first question we are doing is June 2022 paper 2-1. Total currents entering a junction is equal to total currents leaving the junction. A battery is connected to two resistors X and Y as shown. The resistance of resistor X is greater than the resistance of resistor Y. State and explain which resistor dissipates more power. In parallel, voltage is same. So Vx is equal to Vy. Resistance of X is greater than resistance of X is greater than resistance of Y. So I have to make a link in between. Power is equal to V square upon R. Rx is greater than Ry. Rx is greater than Ry. So we can say that look, R is in the denominator. Power and resistance are inversely proportional. So Vy would be greater than Vx. Voltage and resistance are opposite. Y dissipates more power.
I can explain why is Vy greater than Vx.
Hmm. So actually, it's a difference of resistance now. If the resistance is higher, the power dissipation will be less. The two
Oh,
resistors are made of wires that have the same length, but wires are made from metal of the same resistivity. The symbol for resistivity, which resistance is made of wire with the larger cross-sectional area. Actually, remember, resistance is inversely proportional to area. Resistance is inversely proportional to area. So resistance is inversely proportional to area. So I want to have Rx greater than Ry. So it means area is opposite. So area of Y should be greater than area of X. So which wire will be made of greater cross-sectional area? A battery of electromotive force 9 volt and negligible internal resistance is connected in series with a light dependent resistor and a fixed resistor of resistance 1800 ohm. This is the circuit. A voltmeter is connected across the fixed resistor. The reading on the voltmeter is 5.4. Calculate the current in the circuit. Look at this working.
It's 3 into 10 to the power minus 3.
Can you repeat the number?
It's 3 into 10 to the power minus 3.
Calculate the resistance RL of the LDR. We have the current now. Nine volt is the total voltage. So here I can say 9 minus 5.4. So I can say 3.6 volt. Voltage across LDR. Current is the same in series.
It's 1200.
How much?
It's 1200.
1200 ohm. Right. The intensity of the light illuminating the LDR increases by reference to the current in the circuit. State and explain the change, if any, to the voltmeter reading. Light intensity increases resistance of LDR decreases resistance of LDR decreases, and LDR in 1800 are in series. So what is the effect of it? The the two resistors are in series. The total resistance of the total resistance of the circuit decreases resistance decreases, current increases. So voltmeter voltmeter reading increases. Now, this is June 2022. Paper is 23. sketch the IV characteristic of a filament lamp. The filament lamp resistance increases as temperature increases. The graph has a tendency to bend towards the voltage axis. Look at the shape of the curve. Temperature increases, resistance increases, graph bends towards voltage axis. Explain the shape of the graph. So I have explained it here. A conducting wire length 5.8, cross-sectional area this, resistivity is given to be this. Formula resistance is required. The formula is R is equal to rho L upon A. Put the values. I'm just coming in a minute. Put the value and get the answer.
Okay. It's 9.55 points.
all the values in the equation. So resistivity is 5.6 into 10 power minus 8. The length is 5.8 upon 3.4 10 power minus 8.
It's 9.55.
9.55.
Um,
So we can then make it 9.6.
okay.
A resistor of resistance R is placed in a circuit with a cell of negligible internal resistance. Two switches S1 and S2, a second resistor of resistance 2R and 3 ammeters X, Y, and Z. The circuit is shown. The reading on X is 1 ampere. S1 is open and S2 is closed. So we have this one position of the switches.
Reading on Y is 0.
This is the point to see that when the switch S2 is closed, let me close the switch S2. Okay, S2 is closed. If I close S2, current will pass through the ammeter Z. So Z will show me the full current which is coming from the back because the other switch is off.
Yes.
So X, Y, Z. Y will be 0 because no switch open there, and it will be Z will be 1.0. Now S1 close, S2 open. So current will go from the top. The resistor is different. Oh, it's not. Acha. It's basically the resistance is half. So current will double. Actually, R is half of 2R.
Okay.
So current will double in this case because
Yeah.
resistance is half. So current will be double. The resistor at Y is half. Half of the resistor, which means double of current. Acha, now close both the switches. When you close both the switches, the two resistors, one is R, one is 2R. So less resistance means more current. Less resistance means more current. So one is R, one is 2R. So here you will have 2 ampere and here you will have 1 ampere. So the total will be 3 ampere when both switches are closed. So the total current will become 3 ampere. Reading on Y will be 2 ampere. So we have done these two questions. This was a special class for some current questions. And we are stopping here and we will continue in our next class. Thank you. Bye.